Hello everyone. Let's
Hi.
start by hi. Let's start by the homework problem I gave to you the last time. Um, I'll send you the link now. Mm, For those who didn't read the problem, I'll give you like 1 minute or 2 minutes to read it, and then we'll talk about it. Okay. Okay. Let's go through the problem. Okay. Now I'm given an array of n integers, and I know that for every integer in this array, it should be between 1 and m, inclusive. Okay. Uh, Also, the difference between any two adjacent values is at most 1. Given a description of the array where some values may be unknown, your task is to count the number of arrays that match the description. So, for example, this is an array that satisfies this description 222. Every integer is between 1 and m, given that m is 3, is 5, sorry. Um, and for any two adjacent elements, the difference between them is at most 1. So here 2, 1, 2, the difference between any two adjacent elements is at most 1. Here 2, 2, 2, 2, 3, 2. And my task is given an array such that there are an empty elements, like 0 is an empty element. I want to change this element to any integer, 1 or 2 or 3 until m, and I want to know the number of ways to create this array. So for example, let's take this example, 35202. Here n is 3, m is 5, so every element should be at most 5 and at least 1. Okay. And I have to, for any 0 element, I have to change it to any element between 1 and m. So I want to count the number of arrays that I can make. Okay. So here for this example, I could only change this element because all the other elements are set. So what can I change 0 for? I can I can make I can change 0 for 1, so it will be 212. This is one array. Another array is 222. Can change 0 to 2, and I can make it 232. Also, I can change the 0 from 4 or 5, but I cannot put 4 or 5 here because if I made that, the adjacent elements won't be of difference at most 2. Okay, so this is the number of arrays that I can do for this n and m. Okay, let's take another quick example. 0, 0, 0. Let's make it two zeros on. And here m is 2 and n is 2. So for every element, I can make it 1 or 2. And here I have all the elements are zeros, so I can change every element. Okay. One array you can do is 1, 1. I can make 1, 2. I can make 2, 2 or 2, 1. I can make 2, 2. Um, Here are the four arrays I can do. Okay. So the answer for this array should be 2. Of course, for larger arrays, like if I just added another 0, then this will multiply by 2. So I'll have all of this. I could add. So after adding another 0, I multiplied the answer by 2. Okay, so these are all the possible ways. Okay, of course, if I add another 0, then this will be multiplied by 2. It will be 16 possible ways. Okay, so let's see how can you calculate this. Of course, as always, if anyone have any idea, cut me and say it. Okay, so here's a hint. It says that we should modulo the answer by 10 power 9 plus 7. That means that the number should be very large. For these type of problems, we usually use DP. Okay, so the constraints are quite small. M is 100, N is 10 power 5. So I could make a DP with complexity N times M. Okay, of NM. How can we do this DP? Let's see another example here. Let's take this example. So let's define DP of last of I. So DP last I means, so last means the previous element. Okay, last, let's make it prev. Okay, this prev means the previous element, and I means the current element that I'm standing at. Okay, so DP of previous of I means the answer to the ith element such that the previous element equals to prev. So for example, if we are at DP of 2 of 1, here we are 0 index. Okay, 0 indexes. So here for this example, if I'm standing at the second position, I have to call DP of 2 of 1. Why is that? Because the previous element is 2 and the current element, the index of it is 1, and I want to calculate this DP. So I want to calculate the answer for which I'm standing at the second element, index of 1, and the previous element is 2. So to calculate this, we want to make sure that when we call when we are getting the answer, we want to change the current element to either 2 or 3 or 1, because last is 2. So I could change the current element to 2 minus 1, 2 plus 1, or just 2, because the difference should be always 1. Okay, so the answer for this DP will be actually DP of 1 of 2. So I'll call um, I'll go to the next index. So plus DP of 2 plus DP of 3 of 2. Here I'm calling the next I'm calling the next indices to calculate for the next element until I reach DP of some priv of n, and this will be equals to 1. Why is that? N is the last element here. Okay, n is not this, n is this, because we are zero index based. So n is the last element. So until I reach the last element, then now I cannot put any other element. So I return 1, because now I finished an array. So for this example, the answer should clearly be 3, because DP of 2 1 will call these DPs, and every of these DPs will go to the last element here, and this last element we cannot change it, so it will call the last element of DP of prev of n. So here, when we go to, for example, DP of 2 of 2, so DP of 2 of 2, it will just be equal DP of the current element, which is 2, and 2 plus 1, which is 3. And DP of 2 of 3, 3 equals n, will return 1. Okay? So actually, for all these elements, they will all return 1 because this is a complete array. So the answer for this will be 1, 1, 1. So this will be equals to 3. And if, for example, the array was of size 10, and here we had something like this, I don't know if this 10 or not, 4, 5, 6, 7, 8, 9, 10. Okay. If this is of size 10, the answer will also be 3. Why? Because I cannot change any other element. So I'll only, this dp of 1, dp of index 1, I'll call it, um, and change the current element to either 1 or 2 or 3, and then for all the other elements I'll just call, if I am at dp of priv of I and r of I not equals to 0. So if r of I not equals to 0, it means that there is an element in this place. Then I'll just call dp of priv of I will be equal to dp of current, which is r of I plus 1. So for all these elements, I'll call the next element, the next element, the next element, the next element, until I reach the last element, and then I return 1. So it eventually, this only this element is calculated, and it returns 3. Okay. So this dp could be easily understood by doing recursion, not bottom-up approach. So I'll make top-down approach, um, and you'll understand better while encoding. Okay, let's go through it. First, I'll make n and m. Okay, so here I'll have a function called solve int last called priv int I. Okay. Now the base case is if I am at the end of the array, at the element after the last element, I return 1. So if I equals to n, I return 1 because I finished one combination of an array. Okay. Here let's calculate it immediately and then make the memorization to make the DP faster. So now I have two cases. I have a case where I is an actual element in the array which is not 0, so I cannot change it. And I have a case that r of I is 0. Okay, so if r of I not equals to 0, so if array of I not equals to 0, then I couldn't change it. Okay, so I just return solve. Since I cannot change it, then I go to the next element and then try to calculate it or change it or something. Okay, so the previous for the second element will be r of I, right? Because now I'm standing at r of I, so the previous for the next element after me will be r of I. Okay, so that's it. If r of I not equals to 0, then I'll go to the next element. But if it's not equals to 0, then I want to calculate something. I want to calculate all the possible elements I can change. So if it's not equals to 0, then I can make it. I could actually make this return solve. If it's equals to 0, then priv minus 1 I plus 1 plus solve priv I plus 1 plus solve priv plus 1 I plus 1. So here, if this element equals to 0, then I could change it. I could change it to a value of previous minus 1 or previous plus 1. I can't change it more than that, and I can't change it less than that, because the difference should be always at most 1. Okay, but there is another case. and it is that any element cannot pass m, and it cannot go below 0. Okay, so I should check this case. So I just distribute this. I won't make it at the same time. Make int result equals to 0. Okay. So a result should be equal to the summation of solve previous minus 1, previous plus 1, and previous, right? But I want first to check if previous minus 1 greater than 0 first. So if previous minus 1 is greater than 0, then I'm okay. I can change this element to previous minus 1. Okay, so result plus equal solve previous minus 1 I plus 1. Okay, and for previous plus 1, I want to check that previous plus 1 is more than or equals to m. Okay, previous plus 1 is more than or equals to m. Then I'll add to the result solve previous plus 1 I plus 1. And for the last case, I could actually make it here prev I plus 1. So previous is the same element. I'll put this element at the same element as the previous element. So this two will of course be smaller than or equals to m and greater than or equals to 0, and greater than or equals to 1. Okay. So that's it. So now I made it recursion. Okay, this is not DP. I'll make memorization, but now let's take the input. Yes, I want now to return result, of course. See the input. I'll take the array. Okay, so how to call this function? So first I want to call it from the first element, right? I want to call this function from the first element. But what if the first element is 0? So if the first element is not 0, I should only call solve of array of 0. And this should be either 0 or 1. So I'll make it 1. So why 1? So solve array of 0 of 1. So here in the case that the first element is not 0, equals to 0. So if the first element is not 0, then I'll immediately call the second element. Why? Because the first element, I'm sure that it won't be changed because it's not equal to 0. Then I'll call solve the second element. I'll start from the second element, and the previous from the second element is r of 0, right? This is okay. But what if it equals to 0? If it's equals to 0, then I cannot just call solve um, and whatever previous. So if this, let's take this. If this is 0, then I can put this element to 1 or 2 or 3 or anything, okay, to m. So I can put it 1, 2, 3, 4, 5 until m. So I'll have to call solve for each element here. So I'll have to call solve 0, 0, and 1, 0, 2, 0, and so on. Okay. So else, let's take here int answer equals to 0. So I'll go from 1 until m. But there is a case I want to make sure of. Okay. So now I made a loop starting from 1 until m, and I want to change this. I want to call solve such that the first element is the first time 1, 2, 3, so on. Okay, so I'll add to the answer and suppose equals solve I, and I won't call let's call this x to make the naming easier. So for the position, I will not put 0. I'll put 1 because again, I know that the first element, I put the first element now as x. So I want to call solve the second element. So I'll solve starting from the second element, and my previous element is x. Okay, so I'll always call 1, and that's it. Remove this, and I print answer. Before I put the memorization or something. Do anyone have any question? I might have explained some things fast, so if there is any point you cannot understand, ask. Okay.
Hello.
Hello.
This problem can be solved by dynamic programming only, or we can try another method. Means,
Hmm. Actually, any problem you can think of it and solve it with many solutions, but I think the trivial one is dynamic programming. So I don't think there is an easier way to solve this problem with. Okay, so it this is dynamic programming because we want to
and
try all possible ways. Let's say.
means, is there any hint which we can get from the problem that this can be solved from dynamic?
Yes, yes.
How to identify that it is a dynamic problem?
Okay, so I said at the beginning that this is a very good hint that the number of the arrays, I should print it modulo 10 power 9 plus 7. And what does that mean is that the number of the arrays, so the actual answer should be very, very, very large. So it should be something like 10 power 1000 or something that couldn't fit in any data type. So so the actual number of the arrays is very large because as I said here, if I added another 0, I'm just multiplying the answer by 2. So I cannot count it. So here this hint tells me that I cannot count the number of arrays with just going and counting every array once. So DP should always try every possible solutions with the lowest constraints possible. So now, since I know that n and m are small, n times m. So if m was large, like 10 power 5, then this should be hard to solve by DP. So I'll have to think in another mathematical way to solve it. It will be more complicated. So since m is small and m times n is fairly small and can pass, so DP should be fine here. Okay.
Okay.
Okay. And also another thing to make DP solutions come to your head easily is that usually DP problems require you to count things. So if you are to count many things, for example, count the number of ways that you can for each. If you have like 5 places and you are standing at each place and you can jump to the second place or the third place. So at the first time I can jump to here or here. At the second time I can jump to here or here. So here I have many ways to do it. So it's easy to see that this could be solved with DP with only a linear DP. So if I'm standing at position I can go to DP of I plus 1 or I plus 2, and that's it. And the answer for DP of n would be equals to 1. So this is a linear DP. So if I try to count anything like this with that DP, it shouldn't be solved easily. Okay. Okay, let's try this recursive solution without applying normalization. Okay, everything's fine. Okay, let's do the memo array. So memo will be previous, the bounds for previous will be until 100, 101 actually, because m is until 100. And for I, it should be up till m. Okay. And now m set. Okay. So here, if r equals to -1, then I want to calculate the answer from the beginning because I didn't visit this state before. Okay. So if r equals 0, then r will be equals to this. Of course, at the end, I should return r. So here I just make this r. That's it. But there is another thing I want to make the mod. And after applying any plus operation, I want to make sure that it's more than mod. So r mod equals mod. And that's it. And here, of course, cons module equals to mod.
Ahmad, one question here.
Yes, say.
How did you choose 101 while taking the space for DP? Yeah.
Why I'm taking an extra space of 1?
No, why you are taking 101? How you came up with that?
Okay, so m is up to 100. Okay.
Okay.
So for each previous element, it should be between 1 and 100. And so I'll make this 101 because it's zero-based index. So the 100th element will be, the index of it will be 99. So I'll make it 101 because the 101th element will be of index 100 exactly. Okay, did you get that?
Yeah.
Okay.
So space is going to be still exponential, right?
Still to be what?
M equal to some 1 E5 you have written. So space complexity of this will be still exponential, right?
No, space complexity will be n times m, because I'm only using a fixed size memoization array. Okay, so I'm only calling every element from 100 every previous from 1 to 100, and every index from 1 to m, and it's m times n.
Okay.
Okay, and time complexity also will be of nm. Let's try it. Oh, there is an error here.
I'm under the else condition, the R has been predefined, I think, as integer.
Sorry, I didn't get you. Which else condition?
Is this here?
Yes. What are you saying here?
So in the else condition, R has been predefined. We are returning R. It is already
Yes.
defined on top.
Yes, you're right. Okay, thank you. Yes. Okay. Good. So everything should be okay. Let's try to submit. What's the problem here? I think I'm overcounting something because it's giving me a bigger answer here. Okay, let's debug this.
So Ahmed, even in the if condition, we would need to do the modulus, right? In the
We
main
would,
if condition, if array of 0 is not equal to 0.
yes, I'm not applying mod because mod is applied in this function and I'm not adding anything here. Are we speaking about this?
Okay, yes, okay, understand. Thank you.
Okay. Okay, something is overcounted here. Should you figure that out? If it's not equals to 0. Yes. So this cannot be applied except if the absolute value between the previous element and r of I is at most 1. So this is what the problem states, right? So previous and r of I is more than 2. So that's it, but I should add braces here. Okay, so here I'm not calling the next state unless the previous element, the difference between the previous element and the current element is at most 1. So if it's greater than 1, then I won't call anything. Okay, so it will just want to return something. So that should be fine. Okay. What is this one? This one. If it's proof minus alpha I. Small return 2.
So Ahmed, if the absolute value is less than 2, we are not doing in the else case anything. In the else case, our value would still be -1 and it would get returned as -1, right?
Sorry, I didn't get you quite well.
So
Can you make your voice clear?
if array of I is not equal to 0,
Okay.
R is still -1, and we are checking if absolute values are previous and array of I is less than 2, then we are updating R as something.
Yes, you're right. So I should actually say that if I didn't return anything, so it should return 0. So that means I didn't count anything. Yes, right. So it should return, yes. So now, if anyone didn't get that, so if after any calculation it didn't go to the next state, R should be equals to 0, not -1. Okay, that should be okay. I'll give you the code at this one. Here's the code. I sent it on the chat. Let's go to the next problem. Let's see this. Okay, let's see this problem. Let's see this problem. Okay, take 3 minutes to read it, understand it carefully, and then speak if you have any idea. Okay, I sent it here in the chat.